Dear students, welcome to the problem solving session on Fourier series under the interval 0, 2 pi. In the previous lecture, we are solving the problems for the function f of x equal to 1 by 2 pi minus x using the property. In this session also, we are going to solve the problem using the property. For more clarifications, I am doing one more problem. Those who don't see the videos on basics on 0, 2 pi, go to the playlist, watch the video and problems using properties part 1. Watch both videos and come back to here for good continuity. Let us go into the problem. So the given function f of x is x into 2 pi minus x. That means the problem is involving pi. Our interval is 0, 2 pi. So there is a chance this function may satisfy the property. Let us see one by one. As usual, our first step is limits. The given function is defined under the limit 0, 2 pi. I am keep on saying in every video, if you write the limits properly, then you can write the formula properly. Once you write both, then 50% successes happen. Then you can easily solve your problem without errors. Because in tension, you may change the limits. You may write the wrong formula. So have a habit of doing in a systematic way. Step 2. For the limit 0, 2 pi, my Fourier series and the corresponding a0, an, bn formula should be written in the step 2 one by one. Now step 3. Write the property, and we know that if f of 2 pi minus x is equal to f of x, then bn 0. If it is equal to minus f of x, we know an 0 and a0 0. Let us write that both. Now it's time to check the question. Take down the question f of x, that is x into 2 pi minus x. I am going to replace x by 2 pi minus x. Now f of 2 pi minus x is, simply replace x by 2 pi minus x, will be getting 2 pi minus x for this, and then 2 pi minus of 2 pi minus x, 2 pi minus x, 2 pi minus 2 pi plus x. So 2 pi get cancelled, and I am going to get my same function f of x, because when we simplify, we'll be getting x into 2 pi minus x. That is my original function f of x. Therefore, we get f of 2 pi minus x is equal to f of x. Now we can see the typed version. Once we get this, we have to go for the step 3 and step 4. Since f of 2 pi minus x is equal to f of x, you can simply say by the property bn is equal to 0. So now you see 30% of my problem over. Then I have to find only a0 and an. For a0 and an also, I can use the property to convert the limit 0 to 2 pi as 2 times 0 to pi, which is very much helpful in solving my problem, because in the limit 0 to pi, I know cos n pi is minus 1 whole power n, sin n pi is 0, etc. Now let us find a0. Now by the property, I can rewrite this as 2 times 1 by pi 0 to pi f of x dx, and my function f of x is x into 2 pi minus x. This is very tough for me to integrate, so better I can multiply this and I can write it as 2 pi x minus x square. So 2 by pi integral 0 to pi 2 pi x minus x square dx. While I integrate, I'll be getting 2 pi x square by 2 minus x cube by 3. The limits are 0 to pi. Simplifying this, we will be getting 2 by pi. 2 get cancelled. So it is going to be pi cube minus pi cube by 3. Taking LCM, we will be getting 2 by pi, 2 pi cube by 3. So it is going to be 4 pi square by 3. My a0 is 4 pi square by 3. I don't bother much on a0 because I am going to substitute a0 by 2 in the formula. So my a0 by 2 is 2 pi square divided by 3. Next we have to find an. Since an is involving cos and f of x, we have to use Bernoulli's formula. Since cos is involving, again using the property, I can write this as 2 by pi integral 0 to pi f of x cos nx dx. We know that our f of x is 2 pi x minus x square cos nx dx. Now we have to apply Bernoulli's formula. We know that the Bernoulli's formula is integral u dv is equal to uv minus u dash v1 plus u double dash v2 etc. Since my u is going to be 2 pi x minus x square, the highest power is 2. So my integration contains 3 terms. So my answer contains 3 terms. Now u is a diminishing function. When I differentiate, I'll be getting u dash, that is 2 pi minus 2x, u double dash 0 minus 2, and u triple dash is 0. Similarly, dv is equal to cos nx. When I integrate this, I'll be getting v equal to sin nx by n, and v1 is equal to minus cos nx n into n square, and my v2 is equal to minus sin nx by n cube. Now to apply the Bernoulli's formula, we have to map this uv, u dash v1, u double dash v2. Now writing the terms 2 pi x minus x square into sin nx by n minus 2 pi minus 2x minus cos nx by n square plus minus 2 minus sin nx by n cube. My upper limit is pi and lower limit is 0. Now we are very confident that under the interval 0 comma pi, all my sign is 0 when n is an integer. So I can put directly first and third terms are 0. Only second term exists. I have only cos term. I'm writing 2 by pi. Here we can see minus into minus plus. When I apply pi, my upper limit is 0. Minus when I go for my lower limit, 2 pi minus 0 into cos 0 by n square. Now simplifying this, we will be getting 2 pi minus 2 pi into 1 by n square. So pi will get cancelled and we will be writing minus 4 by n square. Therefore, my a naught by 2 is 2 pi square by 3 and an is going to be minus 4 by n square. By the property, we have found bn equal to 0. So now substituting these three values in the Fourier series formula, we will be getting the final answer. Therefore, my answer is f of x equal to 2 pi square by 3 minus 4 times, I'm taking this minus 4 outside, summation n equal to 1 to infinity 1 by n square cos nx. Now we are in the final step, that is deduction. See my deduction, that is 1 by 1 square, 1 by 2 square, 1 by 3 square, etc. Pi square by 6. This is what I have to prove. Now we do one by one. First we do LHS and then we do RHS. Even if you do RHS first and LHS next, nothing wrong in it. I am dealing with LHS. For this I need to choose a point for x. 1 by n square cos nx. If I put x equal to 0, then cos nx will become 1. I can get only summation 1 by n square. If I put n equal to 1 to infinity, I'll be getting the LHS very easily, which is helpful for my deduction. X equal to 0 is the comfortable point for me to get the deduction LHS. So I'm choosing x equal to 0, but when I see x equal to 0 is a discontinuous point. Why? My interval is 0 comma 2 pi. X equal to 0 lies outside the interval. So my LHS I have to write like this: f of x at x equal to 0. For n discontinuity, we have to find the average at the both the limits, f of 0 plus f of 2 pi divided by 2. Since my function is f of x is equal to x into 2 pi minus x. So f of 0 is also 0. F of 2 pi is also 0, because when you put 0, this term will become 0. When you put 2 pi, the second term will become 0. Therefore, my LHS is simply f of 0 plus f of 2 pi divided by 2. That is nothing but 0 plus 0 divided by 2. The answer is 0. So my LHS gets over. Now I have to find RHS. RHS is very obvious. I'm going to put x equal to 0, then cos 0 is 1 as we discussed. Now simplifying this, we'll be getting the answer. Equating LHS and RHS, my LHS is 0, RHS is this. So now I can push this term to the other side. 4 times summation n equal to 1 to infinity 1 by n square is 2 pi square by 3. Now substitute the value of n, will be getting like this. Now 2 get cancel and bring the 2 to the denominator, will be getting pi square by 6, and hence we deduce the infinite series. Answer is pi square by 6, which is the required data. So in this session we have solved a problem using the property where Bn is 0. In the previous session, we have solved the problem using the property where A0 and An is 0. We are going to see the next problem in the forthcoming video where you cannot use the property. That means no other go I have to find A0, An, Bn. So we'll see in the next video. Thank you. Subscribe and share our channel. If you have any queries, post in the comment box. We'll try to help you. Good luck, students. Thank you.